This lecture is about topic mining and analysis. We are going to talk about using a term as a topic. This is a slide that you have seen in an earlier lecture, where we defined the task of topic mining and analysis. We also raised the question, how do we exactly define a topic theta? So in this lecture, we're going to offer one way to define it, and that's our initial idea. Our idea here is to define a topic simply as a term. A term can be a word or a phrase, and in general, we can use these terms to describe topics. So our first thought is just to define a topic as one term. For example, we might have terms like sports, travel, or science, as you see here. Now, if we define a topic in this way, we can then analyze the coverage of such topics in each document. Here, for example, we might want to discover to what extent document 1 covers sports, and we found that 30% of the content of document 1 is about sports, and 12% is about travel, etc. We might also discover document 2 does not cover sports at all, so the coverage is 0, etc. So now, of course, as we discussed in the task definition for topic mining and analysis, we have two tasks. One is to discover the topics, and the second is to analyze the coverage. So let's first think about how we can discover topics if we represent each topic by a term. So that means we need to mine k topical terms from a collection. Now, there are, of course, many different ways of doing that, and we're going to talk about a natural way of doing that, which is also likely effective. So first, we're going to parse the text data in the collection to obtain candidate terms. Here, candidate terms can be words or phrases. Let's say the simplest solution is to just take each word as a term. These words then become candidate topics. Then we're going to design a scoring function to measure how good each term is as a topic. So how can we design such a function? Well, there are many things that we can consider. For example, we can use pure statistics to design such a scoring function. Intuitively, we would like to favor representative terms, meaning terms that can represent a lot of content in the collection. So that would mean we want to favor a frequent term. However, if we simply use the frequency to design the scoring function, then the highest scored terms would be general terms or functional terms like the, etc. Those terms occur very frequently in English. So we also want to avoid having such words on the top. So we want to penalize such words. But in general, we would like to favor terms that are fairly frequent but not so frequent. So a particular approach could be based on TF-IDF weighting from retrieval. And TF stands for term frequency, IDF stands for inverse document frequency. And we talked about some of these ideas in the lectures about the discovery of word associations. So these are statistical methods, meaning that the function is defined mostly based on statistics. So the scoring function would be very general. It can be applied to any language, any text. But when we apply such an approach to a particular problem, we might also be able to leverage some domain-specific heuristics. For example, in news, we might favor title words. Actually, in general, we might want to favor title words because the authors tend to use the title to describe the topic of an article. If we're dealing with tweets, we could also favor hashtags, which are invented to denote topics. So naturally, hashtags can be good candidates for representing topics. Anyway, after we have designed a scoring function, then we can discover the k topical terms by simply picking k terms with the highest scores. Now, of course, we might encounter a situation where the highest scored terms are all very similar. They are semantically similar or closely related or even synonyms. Right? So That's not desirable. So we also want to have coverage over all the content in the collection. So we would like to remove redundancy. And one way to do that is to do a greedy algorithm, which is sometimes called maximal marginal relevance ranking. Basically, the idea is to go down the list based on our scoring function and gradually take terms to collect the k topical terms. The first term, of course, will be picked. When we pick the next term, we're going to look at what terms have already been picked and try to avoid picking a term that's too similar. So while we are considering the ranking of a term in the list, we're also considering the redundancy of the candidate term with respect to the terms that we already picked. And with some thresholding, then we can get a balance of the redundancy removal and also high score of a term. Okay, so after this, then we will get k topical terms, and those can be regarded as the topics that we discovered from the collection. Next, let's think about how we can compute the topic coverage pi sub ij. So looking at this picture, we have sports, travel, and science and these topics. And now suppose you are given a document. How should we figure out the coverage of each topic in the document? Well, one approach can be to simply count the occurrences of these terms. So for example, sports might have occurred 4 times in this document and travel occurred twice, etc. And then we can just normalize these counts as our estimate of the coverage probability for each topic. So in general, the formula would be to collect the counts of all the terms that represent the topics and then simply normalize them so that the coverage of each topic in the document would add to 1. And this forms a distribution over the topics for the document to characterize coverage of different topics in the document. Now, as always, when we think about the idea for solving a problem, we have to ask the question, how good is this one? Or is this the best way of solving the problem? So now let's examine this approach. In general, we have to do some empirical evaluation by using actual data sets and to see how well it works. Well, in this case, let's take a look at a simple example here. And we have a text document that's about the NBA basketball game. So in terms of the content, it's about the sports. But if we simply count these words that represent our topics, and we'll find that the word sports actually did not occur in the article, even though the content is about the sports. So the count of sports is 0. That means the coverage of sports will be estimated as 0. Now, of course, the term science also did not occur in the document, and its estimate is also 0. And that's okay, but sports certainly is not okay because we know the content is about sports, so this estimate has a problem. What's worse, the term travel actually occurred in the document. So when we estimate the coverage of the topic travel, we have got a non-zero count. So its estimated coverage would be non-zero. So this obviously is also not desirable. So this simple example illustrates some problems of this approach. First, when we count what words belong to the topic, we also need to consider related words. We can't simply just count the topic word sports. In this case, it did not occur at all, but there are many related words like a basketball, game, etc. So we need to count related words also. The second problem is that a word like star can be actually ambiguous. So here it probably means a basketball star. But we can imagine it might also mean a star on the sky. So in that case, the star might actually suggest perhaps a topic of science. So we need to deal with that as well. Finally, a main restriction of this approach is that we have only one term to describe this topic, so it cannot really describe complicated topics. For example, a very specialized topic in sports would be hard to describe by using just a word or one phrase. We need to use more words. So this example illustrates some general problems with this approach of treating a term as topic. First, it lacks expressive power, meaning that it can only represent the simple general topics, but it cannot represent the complicated topics that might require more words to describe. Second, it's incomplete in vocabulary coverage, meaning that the topic itself is only represented as one term. It does not suggest what other terms are related to the topic. Even if we are talking about sports, there are many terms that are related. So it does not allow us to easily count related terms toward contribution to coverage of this topic. Finally, there's this problem of word sense disambiguation. A topical term or related term can be ambiguous. For example, basketball star versus star in the sky. So in the next lecture, we're going to talk about how to solve the problem with probabilistic modeling of a topic.